This is section 13.4, part 1. We're going to be working on conic sections of the parabola. And we've got a couple of objectives. We're going to be graphing horizontal parabolas and identify conic sections by their equations. So we're going to be doing these things in the future. This is really kind of an intro to parabolas. We're going to be doing some review stuff from Algebra 1. And so the definition of a parabola is the first thing. A parabola is a set of all points in a plane that are equidistant from a fixed line called the directrix and a fixed point called the focus that is not on the line. So it looks like, say we got a parabola here. You all know what a parabola looks like. And say we got a point here. That would be our focus. If I can write focus. Okay, there's our focus. And this parabola, there are points that are the same distance away from the focus as they are a line down that goes through down here, which is called the directrix. So this line is called the directrix. And so any point on this parabola would be the same distance away from the directrix as it is the focus. And there are ways to find the directrix and the focus and to find the parabola from the directrix and the focus, and we'll get into that. But right now, we're just going to be talking about our regular old vertical parabolas that you learned in Algebra 1. And the different forms. And so we have a form here, y equals a to the times x minus h squared plus k. That is standard form. And you have general form, which is y equals ax squared plus bx plus c. So, by the way, you can also substitute in f of x for either y. So f of x is possible in terms of a functional notation. So it could be f of x equals a times x minus h squared plus k, or f of x equals ax squared plus bx plus c. And on this one, the left one here, the vertex is same as the vertex always is. It's h and k. Right in the formula are h and k. But you got to remember, h is minus h. So that means this tells us it's going to be opposite. Whereas k is plus. So you got a plus there. K is going to be the same. So when we do this, and you'll see in the problems, h will be opposite and k will be the same. And that's only for vertical parabolas. Parabolas that go like this or like that. That open up or they open down. And whether or not they open up or down is dependent on A. So our A in our formulas, either formula, doesn't matter. They both have an A. If A is positive, you get a parabola that opens upwards. So we could do 1, 1, 2, 4, negative 1, 1, negative 2, 4, and 0, 0. And if A is positive, you get a parabola that opens upward. If A is negative, you get just the opposite. It's going to open downward. So 0, 0, 1, negative 1, 2, negative 4, or negative 1, negative 1, negative 2, negative 4, and it would go on from there. And that's our two parabolas. Now, the other thing that we have that parabolas have, is what's called an axis of symmetry. And that is always going to be equal to the x component of the vertex. So in this case, in these cases, the vertex is at 0, 0. Our axis of symmetry would be y equals 0. sorry, x equals 0. I said that wrong. Our axis of symmetry on both of these would be x equals 0. Let's look at the next page to do a couple of problems. All right, so we want to find a couple of things, and that's all we're going to be doing in tonight's homework, is just finding these three things for the 4 different types of parabolas. You're going to be finding the vertex, the axis of symmetry, and the direction of opening of each parabola. And it could be in either form. It could be in standard form or it could be in general form. So in this one right here, you got, for A, it's y equals -2, x minus 3 squared plus 8. First thing we want to find is the vertex. Vertex. The vertex is h and k. Remember, h, we said, is the opposite sign. So if this is h and that's k, we're going to have opposite sign for h. It's 3 and same sign for k, so it's 3, 8. Second thing is the axis of symmetry, and I will just call that A of S for short, axis of symmetry. And that is equal to the x component of our vertex, so it is x equals 3. And the third thing is it's going to open up or down based on A. My A is -2, so it's going to open down. Let's look at B. B is quite a bit different. The vertex on this, and you know what, I forgot to tell you this on the notes, but when you have it in this form here, the vertex is found by, so that's 1, 2, 3. Vertex is found by -b over 2a and f of -b over 2a, which means we're going to figure out for the x parts of our vertex, we're going to figure out what -b over 2a is. Remember, we've got a, b, and c for this form of our equation. I can write those much better. A, b, and c. So we're going to do -12 over 2 times 3. That's what we get for x. -12 over 2 times 3. But for y, we're going to do f of that. So whatever -12 over 2 times 3 comes out to, we're going to do and plug it into the function, that number that we get, plug it into this function right here to find y. And so we're going to get -12 over 6, which is -2. And so for the y, we're going to do f of -2, which means we're going to do 3 times -2 squared plus 12 times -2 plus 8. And I'm going to have to put the 8 down here. -2. Okay, and that's going to finish our vertex. We're going to have -2, and if we figure all this out, it comes out to -4. Now, the other two parts work the same way. The axis of symmetry is just going to be the x component. So the A of S, the axis of symmetry, is going to be x equals -2. And it's going to open up or down based on A. If A is positive, it opens up. So, opens up. And that's how you do B. Those are the vertical parabolas. Vertical parabolas will either have f of x here or they will have y here. If it's a horizontal parabola, it's going to look a little different. You're going to have, so now we're on horizontal parabola, you're going to have x out here And you have two different forms again. You have the form where it's a times y minus k squared plus h, and you have one where it's x equals ay squared plus by plus c. This form is the easier to work with, just like in our vertical. The standard form is always the easier one to work with. The general form is much harder to work with. So these are for parabolas opening left or right. Obviously, A tells us which way they open. If A is greater than 0, which means if A is positive, it's going to open to the right. If A is negative, it's going to open to the left. The vertex of, if it's in this form, is still H and K. The axes of symmetry, which would be this axis right here, is going to be the Y component, and I have that written down here. Axis of symmetry is equal to the Y component of the vertex, so it's going to be Y equals K, whatever K comes out to. And if here A is negative, then it's going to open to the left, because it's saying A is less than 0. And if A is positive, it's going to open to the right. To find the Y coordinate of the vertex in this form, you're going to get Y equals negative B over 2A this time. When it's in this form here, or actually this form here. We're going to do negative B over 2A to get Y, and then we're going to do F of that to get X. So, let's do the two problems. It says find the vertex, the axis of symmetry, and the direction of opening of each. This one is in the form we like. The first one is in the form we like. It's the easier of the two. This is K. This is H. And so our vertex. And remember, this time the K is opposite. So our vertex, instead of being -1, is going to be a +1 for K. I'm sorry. It's going to be a +2 for H and then K. It's H and K, not K and H. 2, 2, and +1. Okay. K is the opposite. Instead of being a -1, it's going to be a +1 in this case. Remember, in the vertical parabola, H was the opposite. So it's really whatever one is in the parentheses here, that's the one that's in the opposite. That is opposite. So in this case, K is in the parentheses, so K is the opposite. The axis of symmetry. This time it is the Y component. Y equals 1 is going to be the axis of symmetry. And the last thing we got to find is the direction it opens. If A is negative, it's going to open to the left. So it opens left. Can't spell. Opens left. Okay, B. We're in the other form. The vertex, again, is not the easiest thing to find when it's in this form. We see up here it says Y for our vertex is negative B over 2A. So our vertex we don't know the first part, but we know this is going to be negative B over 2A. Well, we know it's going to be F of that. F of negative B over 2A. So we've got to figure out what negative B over 2A is first before we can start plugging in the numbers here. So we got negative B is, so we got A is the 1 in front of the Y. That's B, and that's C. We're going to do negative 4 over 2 times 1, which comes out to negative 2. And for this, we are doing F of negative 2. So F of negative 2 and negative 2. Well, F of negative 2 means plug negative 2 into the equation. for the y's in this case. So we've got negative 2 squared plus 4 times negative 2 minus 5, and then we've got a negative 2 for the y. And if we simplify all that out, we get negative 8, negative 2. That's our vertex. So it took all of that to get our vertex. The second thing, axis of symmetry. Axis of symmetry is just the y component of the vertex, which is negative 2. So y equals negative 2. And we know it's the y component because x starts us out, and so it's going to open to the right because a is positive. So opens right. Let me fix that. Opens to the right. So you can read it. There we go. That's all for this section. I will see you in class.